So here we have a related rates problem, and I'll read it out. A street light is mounted at the top of a 15-foot tall pole, and a man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of the shadow moving when he is 40 feet from the pole? Alright, so we can kick it off, close the door, with a little diagram to illustrate this. So we'll have the pole 15 feet, and we'll have the man 6 feet. He'll be moving this way. It doesn't really matter as much for this diagram, but we'll have x is the distance from him to the pole, and that's one of the things that we're concerned with is when he's 40 feet from the pole, that would be our x. And y will be the shadow that he casts. And we can complete this triangle like that, because we found a base and a height, and we can just connect it. And also, with him in the middle, we have a similar triangle, because these angles are the same. So we can have a ratio of the base to the height, which would be 15 is to x plus y, which would be the whole base, equals 6 to y, which would just be the base and height of that triangle. And we can simplify this with cross multiplication. And we can cut it down even more to isolate y. So we have that, which is the relationship between x and y in this case. But that doesn't deal with the rates yet, because we're trying to find the rate of change of the shadow when he's at 40 feet. So what we'll have to do is, what are we trying to find in the problem? Rate of change, which will have to be a rate of a derivative. So d over dt of x plus y, which would be the whole shadow it casts. Because here's the light source, and the shadow will be cast all the way down to y with an end. So we're not just dealing with y or just x, we're dealing with the whole length, because that's where the shadow is being cast from. We're trying to find the rate of change of the distance of x plus y. That'll be our Waldo. Where's Waldo? And what we'll have to do is we can, now that we have a relationship between y and x, we can make this even more simple by saying that d over dt of x plus y is the same as d over dt of x plus 2/3 x, because we said over there that y equals 2/3 x in the relationship of this similar triangles. So now that we have this shouldn't be too hard to simplify. So we have d over dt, x is the same as 3 over 3x, because 1, so we can just say similar denominators. So we have that. Cut it down. Combine like terms, so we have 5/3 x. And now we know how to do this, is that we take the coefficient out. So 5/3 d over dt is what we have. And we have a given in this case, which is that he's moving away from the pole at the speed of 5 feet per second. So here is his distance from the pole, and this distance is changing 5 feet per second. So we know that dx dt equals 5 feet per second. So now that we have that, we can make a connection that, there it is, dx dt, plug in 5 feet per second. So 5/3 times 5 feet per second, which is dx dt, equals 25/3 feet per second. And so what we just found is d over dt of x plus y, which is the rate of change of the whole shadow from the light pole, by doing the derivative and then plugging in x with y with a relationship, and then plugging in the given to find this number right here, which is our solution. And that is relative rates.